Hi, my name's Warren. Welcome back to this Intro to SQL course. Okay, in the previous video, we created some tables to try and show how joins work. I've written up all of these scripts with some explanations here to show you how we can do joins on the data that we created earlier using our customer, employee, product, and sales transaction table. So there's a lot of information here. You can see that I've gone and pre-written these scripts out just that I don't have to take up time typing them out, but we'll go through them one by one and I'll explain exactly what's going on. So what we want to first do, we want to join our sales transaction table and our employee table. So in other words, we want to be able to see employee detail for all the sales transactions. So if we want to look at those two tables for starters, we can execute and we can have a look here. So here we have our transaction table and here we have our employee table. So what we want to be able to do is join employee ID in our employee table to employee ID in our transaction table. So that's what we want to do. We want to join these two to be able to not, if we had to show a user this table, it wouldn't make any sense. They would want to see the names of the employees. So what we want to do, we want to select employee.employee ID, employee.firstname, and sales transaction quantity. Now you might be saying to me, why are we putting employee in front of this? In the previous video, I explained that you might have, well, we know for a fact that we have employee ID in both tables. We have employee ID in our sales transaction table and we have it in our employee table. So if we just put employee ID here, SQL wouldn't know what table to pull the data from. That's why we put the table name in front. So we want to extract from the employee table the employee ID, and we want to extract from the employee table the first name. And then from the sales transaction table, we want the quantity. So we want the quantity from here, and we want the first name and the employee ID from this table. So we have to have a from statement. So we say from employee, and then we want to inner join. So we only want the data that is in both tables. So in other words, if there was an employee in this table that didn't feature in our transactional data, we don't actually care about that. We only want to see what's in both. That's an inner join. So we want to select this from our employee table. We want to join onto our transaction table on. We always need to join using the on clause. We want to take employee.employee ID. So this employee, we first name the table, then the column. So employee table, the column is employee ID, where that is equal to sales transaction.employee ID. So just like you do in Excel, a VLOOKUP, you're taking employee ID and you're looking up, well, we're taking the employee ID in the sales transaction field and table, and we are linking it to the employee table, and we're pulling back the related first name and ID. So let's see what that looks like. So here you can see we have one result. This is coming from the employee table. This is coming from the employee table. And this is coming from the sales transaction table. So we've joined the two tables and we've returned a result from the two. So now what we can try and do the exact same transaction, but we can do left join. Now, because we have that relationship defined where there's a primary key and foreign key, we can't do the inverse from the sales transaction table back to the employee table, but we can do it from the employee table back. And I'll show you examples of that. So let's have a look here. Here we're getting the exact same information because the inner join and the left join, there are no records that are not common to both. So whether we do a left join or inner join, we're getting the same result set. Okay. If we do a right join, we're going to get exactly the same result because whether we're looking at all the data from the right, the left, or common between, there are no records in either table that are not common to both. So that's why all of these will return exactly the same result. That's why I had to do the previous video to create tables that had discrepancies between the two to show you exactly how the different variations of joins work. So let's go and compare product and employee. So we're going to look at those two tables. Say we wanted to create a list of all the products for each employee. So say it's like a check sheet where John has to have a list of all the products, Jane has to have a list of all the products, Bob, etc. So in other words, we would want every one of these records to be assigned to every one of the records in the employee table. How could we do that? We can do it with a cross join. A cross join will take every record in here to every possible variation in here and give you a result set. And how we write that? We just write select star. That'll give us all the data from both tables. From employee, cross join product. We don't need to declare a field or a column because we're taking every possible combination. So if we execute that, you can see John has got a list of all the products. Jane has got a list of all the products, and so forth. So it's created one big table with every possible combination between the two tables. So that's where we need to be careful. If you're doing this on two tables that have millions of rows in each, it's going to create a Cartesian product probably of billions of records. So you need to be careful. Now, if every time we want to write out the columns we want here, and we have to go and write out the whole table name every time, that could become quite painful. So what we can do, we can create, like we did with columns, we can create aliases for the table. So if we have a look here, we can say select star from sales transaction table, and we're giving that an alias of S. And we want to join it through an inner join on the product table, and we're giving that product table an alias of P. So now every time we need to refer to a column in either one of these tables, we don't need to type out this entire thing. We can just use S for sales transaction and P for product. So here we can go and say S.product ID, which is actually sales transaction.product ID, is equal to product.product ID. There again, we're using an alias. And if we run this, you can see it understands perfectly what we mean. Again, if we wanted to get a little bit fancier, we can go and we can do a join on a more advanced query. So here, we might want to do one like we did before, where we have product name. We want to know the total quantity of by product from the sales transaction table, but we don't have the product name in our transaction table, so we need to join to the product table to get the product name. And on that, we need to join the product ID between the sales transaction table and the product table. And because we're doing an aggregation here, we need to have a group by, because if we don't have the group by, it will give us that group by error that we've seen before. So if you see here, there's an aggregate function and there's no group by clause. So here we're combining a lot of what we've already learned. So we are joining our sales transaction, which we're now naming S, to our product table, which we're now naming P. We're joining those two tables using the on clause between the product ID in the sales table and the product ID in the product table. We are then saying return the product name from the product table. That's why it's p.product name. We're giving that an alias to be called product name in our result. We're also saying please sum the sales transaction table quantity field and call that result total quantity, and then group it by the product name. So any field up at the top here that is not an aggregation needs to be included in the group by. So now we run all of that. You can see each product, it's called product name because we defined that here. Total quantity is the sum of the quantity here, and we're grouping it by the product name. So the product name here comes from the product table, and this aggregation comes from the sales transaction table. So you can see how powerful the joins are. We now have the ability to pull that text field with the description into our result through a join. Here we can do an even fancier one. Here we want to go and we want to join the sales transaction table. We're going to call that S. onto the product table, P. But we also want to be able to show the employee that sold the product. So you can do multiple joins. We're going to join to the employee table as well. So here we're going to have two joins. We're going to join the sales transaction table to the product table through the product ID and to the employee table through the employee ID. Every time we name a table, we're giving it an alias. So S will be sales transaction, P will be product, E will be employee. And then we're going to do a sum of quantity times by the unit price to get the total sales amount. We're going to return the product name from the product table. We're going to take the first name and the last name, like we did before. We're going to concatenate them together and we're going to call it employee full name. And then we are going to group this result set by product, because everything that is not an aggregation needs to be defined in the group by. And because we are doing this fancy concatenation here, we need to include that in the group by at the bottom here, because that's part of our group by. And then I want to order it by the employee full name. So the concatenated first and last name. I want to see the employee's full name and the total sales amount descending. So here you can see we're combining so many things that we've learned before. We're doing the joins, multiple joins. We're doing aggregations. We're using aliases. We're using concatenation. We're grouping by, and we're ordering by, all in one SQL statement. So you can see we can get really fancy and do some powerful things. And here's our result. We have the full name, Amy Johnson, the product, the quantity, and the sales amount. And you can see it's descending on sales amount. The first product she sold is $479, the second one $299. Then we go on to Bob. Bob is $199.69. Jane Doe $174 to $149. So you can see it's sorting their column descending. So here you can see we can do really, really nice SQL statements to get a lot of valuable data. So that's what joins are. I've got a few other examples here where we can create differences in the data, but I covered that in the previous video. Initially, I was going to show you off our data, but I think that's just going to be rehashing what we did in the previous video. Just understand that you can use left and right joins to see if there's data missing in a specific data set. And if you use the inner join, you're only going to return data that is common in both. But here you can see we can actually combine a lot of the info or a lot of the skills that we've learned in one nice SQL statement here to return a nice result. This could be used in a BI report or in a daily report or whatever the case. So I hope you enjoyed that. In the next video, we will start looking at, I think we're going to start going into a more advanced topic. We're going to start looking at subqueries. So I will chat to you in the next video. Thank you.